Good morning. I'd like to give a few comments on my September 2024 newsletter. So I start out with what is wrong with software. Simply put, what I said in the newsletter is that hasn't gone anywhere. We're still at the very fundamentals of software development, probably less so than when we started. We have basically 5 or 6 instructions, hardware instructions at the hardware level, and variations of the same 5 to accomplish other instructions. So the basic technology is the 5 instructions. The other ones are simply manipulations of the same technology. For example, it said that we have a basic instruction of subtract. Well, where's add? Well, we invert one's complement for two's complement, depending on your system, basically, and then do a subtract, and that becomes an add. How do we do multiply? And so on and so on. And so there's a whole lot of misconceptions on what software is. And then I look at the different technologies, the computer technology, what exactly is that, which is our 5 or 6 instructions. Next, software technology, which we have in all of our computer languages, whether it's assembler or so-called high-level language, it's simply 5 basic statements in all languages, whether it's Fortran or Cobalt or assembler or C or C Sharp or Go or R or any of these other languages. It's the same identical statements, which is we declare something, some variable, assign, calculate, compare, and jump. And that's it. That's all we can do. Then I talk about software creation, which is simply, how do we do this? We use an 1868, 3 years before the Civil War, typewriter. One line at a time, one dimensional, go along the x-axis, and then we move the paper up. And the keys, our limited keys character set is obnoxious. We have to shove everything in a black and white technology, so we haven't gone anywhere. We could have done this in 1868. We could have programmed, and actually we did program prior to 80s or so. Ada Lovelace publishing her first program. Wasn't hers, but she used a spreadsheet to do add, subtract, multiply, and divide in columns. And there were two values that you wanted to add, and she did that. Now this idea came from Babbage. She worked with Babbage, Charles Babbage, in the analytic engine. And well, Babbage got his idea from Baron de Parnay. And Parnay got his idea of breaking our instructions into opcodes, because he was doing log tables and navigation tables by doing human computers and breaking the problem up into 2-column tables, which is what we do. We have an add, we have 2 registers, and we perform an operation. This is our hardware. Now Parnay got his idea from Adam Smith, 1776. Wealth of Nations is when he published his book. And it's my belief that even though he published it and put this idea of breaking complex problems like math equations or whatever into 2-column tables so that you could hire high school kids to, Parnay did it, instead of having one mathematician go do a complex. It was very difficult to validate then, but 2-column tables is really easy to validate. Adam Smith worked on Wealth of Nations. I'm sure everybody's familiar with that. But I believe David Hume had a huge influence on Adam Smith. They were friends. David Hume was a philosopher. He was a big advocate of Isaac Newton, who did scientific method. And that was to validate the existence of God. We need to know, or at least this is his efforts were to somehow not just take everything in faith, and that was David Hume. But they were friends. David was 12 years older, and they met when he was like 22. Adam Smith was 22, and I think, or 20, and then David Hume was like 32. So anyway, some 12 years difference. Anyway, back to, and this is my start for computer science, even though the could have been going back to the Babylonians 3,500 years ago when cuneiforms were being used or started, and it took them 1,500 years to perfect that technology. Every 500 years, they would improve it from pictures to symbolic gestures of sticking to clay, and that improved, and that's how our writing began. This was prior to hieroglyphs and things like that. Anyway, I think it's important to know history of what we're looking at, and has the basic technology improved? That's all I was trying to say. And I say no. I've been in this 50 years and I don't see any improvement. I graduated the University of Houston, computer science, and they're teaching the same thing now than when they did 50 years ago. So I want to improve technology. And an improvement is not just manipulation of, oh, you say, well, AI is going to do it, or this. It's not. It's simply programming. It's taking our 5 instructions and trying to represent knowledge. So we decide that 65, the bits represent a number, and we come up with a convention for the first one represents 0 and 1, a value of 0 or 1. Next one is power 2 and 4 and so on. And this is not a new concept. This, I think, was done about 2,500 years ago. So binary systems are not new. And we don't need to use binary systems. We use it for our convenience. It's easy for humans to understand. The computer doesn't need it, but that's the path we went down. I think we should go to a different base than base 2. I think we should have all bases. So we could do a base 3 or base 4 or base 5 or base 4,000. It's irrelevant to us, to the computer. I'm talking about the computer. To us, it's simple because we can understand it. And that's the problem, is we're putting everything in our whole technology into what humans can understand. And it's not our understanding that needs to understand this, it's computer. And is it more efficient? To tell you the truth, I don't care about efficiency anymore. We're wasting so much time on efficiency and speed that things are failing. We don't go for perfection, we go for speed. Speed has nothing to do with logic. We could have written all of our programs and used the analytic engine of Charles Babbage to do our computing. We're doing the same operations. It had a compare and a jump and a branch and all this other stuff, probably more efficient than what we're using today. So we want to improve the technology of computer. That's what I'm after. So what? So we say, oh, well, we'll create better applications. We've been writing stupid applications forever. None of them work. So what would be the improvement? To the technology, not to the manipulation of our 5 or 6 instructions. That oh, well, we'll build a better screen. But the technology doesn't change. It's still a matrix of dots, of colors. That's and then we change them quicker. That's a video. We have pictures and videos, and then we can draw lines and we can draw graphics, but those are just manipulations of the same technology. So it's like a car. We can put a radio in it, but that has nothing to do with the technology of the car. And the technology of the car is really the engine. Has nothing to do with the wheels or the steering or anything else. Those are just convenience for us to be able to manipulate it. But the real technology of transportation for us, a change, is the engine. We could not fly airplanes without an engine. So transportation is really the engine, not the device that we assume is a, sure, there are billions of technologies in a car. Somebody has to do rubber, tires, could have been wood, anyway, and carburetors and fuel and the road systems and billions of other technologies, but those are not directly related to the car or transportation. Okay, so we want to improve technology. My thing is currently our technology is based upon human involvement. Means that every application we write, it's one person, you can say group, but it's actually one person that makes a decision on how to create an application. And that application is human crafted. Now, anytime you type something in, the probabilities of error is quite high, probably 93%, 7% error rate in data entry. We have a lot of technology that looks at data entry. I have dyslexia, so you let me type anything, the numbers are going to be backwards. I type in characters backwards. It happens. And there's a lot of reasons. And basically a lot of it is personal preferences. Oh, I went to Harvard and they do this, or I went to MIT and they did this. They think that, red, black trees are better than ABL trees, or some convention that is personal preference, or he knows it better, or he uses hash tables, or but that has nothing to do with the technology. Okay, back to the change of technology, what I want to see is take the human out. We cannot write programs, not perfectly, we can write static applications. All of our applications today, operating systems, can't change. They're static. We can't read or understand our own programming languages. Not really. There's too many internal and external dependencies within the code itself and conventions that Unicode, I have a lot of hates, and I think Unicode is probably on the top. It's an application for it. And they just it's not a technology. It's just somebody's application. We'll do it this way. We'll group them this way. We'll repeat the character A 1,000 times. That's not a technology. Okay. But we must have the ability to remove the human from software development. We don't need them. Not really. That's what I've been working on 10 years. How do we do this? Well, I worked on 10 years. It's hard for me to say one thing, but basically we let the computer do its own programming. We don't need I could tell you what programming is. Okay, programming is having an action. All the computer do is do an action. What can it do? It can move binary values around. And when it gets to the physical devices, it can turn a motor. It can show images on a screen, And that's about it. And our data types are, I could tear it apart all day long. I could sit here all day long and tell you war story after war story of what doesn't work. Our latest and greatest Microsoft outage, yeah, that was a good example of simply humans cannot make changes to its own environment. Okay. So that's one thing, get the human out. Okay? The next thing is have the ability to change software. When we write an application, any application, it's going to get stale. It's not going to fit everybody's needs. Basically, it's back to personal preferences. Does that piece of software perform exactly as everybody needs? No, it doesn't. So what we really need is for the end user to determine what he wants, not have some programmer in some closet deciding that we don't like go-to statements. I don't like go-to statements. I personally don't like it, so I'm not going to put it in there, so screw the world. I'm sorry. It's not your decision. Who cares? And same way with everything else. You know, anyway, that's a whole different subject of personal preferences that we are forced to live with because they can't write software. I used JavaScript as basically a dynamic structure creation, which is fine. You can have dynamic and static, and so my compiler basically, I took about 29 of the popular languages, and they're all identical. There really is only about 200 characters of difference between any of these compilers, literally. That's how trivial it is. They all do the same thing. And it's not the compilers that we're looking at. It's the supporting predefined functions, collections of statements that they supply you. Java, I wrote a bouncing ball program in 9 different languages, doing the same thing, okay? Create a region on the screen and bounce a ball around it, okay? Wall to wall. And I did that in 9 languages. It took me about 3 or 4 hours for each language, but I had to go through documentation and what's your origin? That was a big one, okay? You know, and all of these things have nothing to do with the technology of creating software. It was all, Java had their origin as lower left. Most of the other languages had it top left. So that changes the whole logic of the application. So it's very logic specific to the language that you're using. I want to create something that automatically creates your applications in seconds. So you want an accounting systems compilers. Like I said, I did 29 of them, and there's very little difference. Same way with accounting systems. It's just the qualifiers that we want to apply to the application. I run a 10-bed hospital in Houston. Create me a hospital management system with HR and billing and supply and procurement and all the other subsystems that we need to know, HR and everything, and then tie in all the state and federal laws that apply to me. Being in Houston, it's different than if I were in San Antonio. San Antonio may have different rules for building codes, or you know, we have all these variations which are simply qualifiers. So when I took the languages, they were just simply qualifiers. That's all the applications that we have are simply qualifiers. Yeah, I want it blue, I want it green. Simply, how do I tell it that? And AI, this stupid AI, I don't even understand what it is. Somehow they're going to say it's going to do something. To me, it's just an application. So once it changes, then every user, once we get where applications can be changed, created dynamically and modified, then I could say, look, create me a compiler. I want a JavaScript compiler that generates ARM instruction sets, and I want a go-to statement in there. And I want the C++ declaration statements. I disqualified my application. The system, my system, Jane, can do that and say, oh, he wants that. I'm already set up to do this. And I do this for every application, whether it's an operating system. We shouldn't have operating systems. We should have compilable applications that can be bootable. That's all we really need. And if you want to write your own operating system, you say, look, I want an operating system. I want this type of whatever, disk structure. I want these naming conventions. I want, whatever it is. And that way we can make modifications to the fundamental logic that is being used to create these applications. That's what I'm really after. I'm not really it's important to be able to, for the end user to have complete control of their hardware, their software, and their own information that they create. That's the end result. But my result is I want to be able to make modifications to any application so that I don't have to go in and program it. That takes the human out of it. Okay, so that's my improvement to the technology. This cannot be done in our existing technology. This is not adding new statements. This is not polishing what we already have. We could say, look, cars now have radios that transmit or something. I don't know what else you could put in a car. But those technologies are not the car technology. I'm saying, what is the fundamental technology of computers? And I started looking at what we're really trying to do is we're trying to get knowledge into our systems. And with this capability of dynamic applications means that we're really trying to accomplish knowledge transfer. All of our current applications are isolated. They don't talk to anybody. And the reason for this is pure greed. Nobody, no company out there wants to lose money. So Apple makes phones that you can't fix. Cars are being made so that you can't even buy the parts to repair them. And so on and so on. It's they're trying to rent you your own information. Your own hardware that you purchased, you don't own. You can't do anything with it. If it breaks, you have to go to a dealer. Look at, John Deere. And it's getting worse and worse. So I'm saying we need to give all this knowledge and power back to the individual user that buys software and buys hardware. It's their hardware, it's their software now. It's not yours. You want to sell it to them, you want to rent it, that's something else. But my system is that you buy the software, you get access to the 100% of the source code. Literally. Anything that it possibly. Plato says there's certain information that you should not publish to the general public. I understand that. You don't publish how to make bombs or medicine. That I think is wrong. I think, and that's knowledge. Basically, any company out there that's doing anything with knowledge, how do I make an aspirin? How do I do this? They do not publish. They do that for their own benefit. They do not do it for humanity. All these companies will keep that. Anyway, and so my conclusion was basically, if we do this, software companies can't control you. And we should be able to repair all of our hardware, all of our software. This really applies to all technologies because computers actually control all technology, mathematics. If we can get better technologies in creating better mathematics applications, I mean, it's ridiculous that, well, I'll get off my soapbox on that part of it because it's really bad. We're still in black and white, 1868 typewriter technology to write our programs. We have upper and lower case, which was Gutenberg technology. So we're We can't use color, we can't use underlining to mean anything in our applications. We can't even format our own text. You know, we, we have, we have forms that says, you want to create a file, give me a name. And it does it one at a time. So it takes you fucking forever to create 3 files. Why don't you just let me type in 3 names? This is, come on people. These are trivial logic. We have no flow control in our applications. We have no formatting capabilities in our applications. We have no units. We have no anything to get anywhere. Our technology, I said 270 years, we haven't done anything at all. And I hate it. This is supposed to have been my profession, and I hate it. I hate writing software now because it's so stupid. Anyway, off my soapbox. I appreciate your time. I hope that my newsletters basically cover all the technology that software is not doing, and we can really get rid of. We don't need programmers. We don't need companies telling us how to program, which is all they're doing. Our debuggers are getting worse and worse. We should be able to program in mathematics as we write on paper. That's we have technology or music or anything else. Well, thank you for your time. Take care. Bye now.